Hello everybody and welcome to Unit 2. This unit is going to cover plate tectonics. So I'm going to start with this image here, and if you want, take a moment to try to figure out, number one, what it is that we're looking at here, and number two, see if you could find on the image here the state of Alaska. Go ahead and pause and take a moment for that. Okay, so what we're looking at is Pangea, and you can see here it has it labeled with all of our modern political boundaries. This was a supercontinent. We call it a supercontinent because it was all of the unique continents that we have today smushed together into one big landmass. We think this was about 300 million to about 150 million years ago. Ballpark, very, very broad estimation. This is about dinosaur age, about dinosaur years old. Yeah. So we're going to cover first the development of plate tectonic theory, how we've gotten to this, and we're going to start with Alfred Wegener. Uh, so he existed back in the days when scientists didn't just study one particular thing, but maybe could have covered all sorts of different areas. See, he was a meteorologist, he was a polar researcher, he was a geophysicist, sort of had his finger in all of these different areas. And he is known for being the first one to propose this idea of continental drift, or at least the first one to present it formally and to tie all the pieces together into one idea. And his idea was that the continents, as we see them now, had not always been in these places relative to one another, so that they have moved through the earth. This one went this way, this one came down, this one came over here. And he supported his idea with a few different things. First, the geometry of the different continents, looking like they fit together, but also geology, which seemed to, in some ways, extend across continents which are nowhere near each other. And finally, the distribution of fossils, some of the most convincing evidence. And spend a little time on this one, seeing now this is the very southernmost piece of that continent that we were looking at earlier. And you can see that putting the continents together like this, all of a sudden the distribution of fossils makes sense. For example, the Mesosaurus, here we see a freshwater reptile. We have fossils found in the southern tip of Africa and the southern tip of South America. Well, today, those 2 points are thousands of miles apart. So, which is the more likely explanation for finding these two fossils? Was the Mesosaurus swimming across the ocean? Again, a freshwater reptile, which we think is about 3 feet. Or were these two places originally side by side? And this was actually Wegener's map, which he proposed. And even though this looks incredibly crude and almost useless by today's standards, he was still the first one to do it. Somebody had to be the first one to try to reconstruct what the continents looked like in order to be able to explain all of these different unusual patterns that we were noticing. And part of this is what he couldn't explain. What he couldn't explain was what the driving force behind the motions were. So he could say that these continents are moving, they haven't always been in the same place, but part of what was a weakness of his idea and what made it difficult for other people at the time to accept his idea as being true was that he could not explain what the driver was of this. What force could it possibly be that is moving entire continents, pulling them apart from each other and smashing them together like this? We're going to cover that in the next section.